Hi everyone, welcome back to Data Cadence. My name is Rahul. I work as a senior applied research scientist, and in this video we'll tackle a very fundamental interview question asked in computer vision interviews, that is, what is the purpose of a pooling layer in a CNN. So I'm sure if you would have ever built a convolutional neural net, you would have used pooling layers, but this question will serve as a refresher as to why exactly these pooling layers are needed in a CNN architecture. So pooling is a downsampling technique used in convolutional neural nets to reduce the spatial dimensions while retaining the essential information. Now, pooling is quite essential in a successful CNN architecture, and we'll understand why. So why pooling? The first thing is that pooling helps in making the network more efficient and robust by reducing the number of computations that will happen. It helps control overfitting. How? By reducing the number of parameters, therefore improving the generalization ability of the CNN to learn more robust features. And it also helps in enhancing the translational invariance. Now, this is a term that you would or would not have heard before. So translational invariance refers to the ability of the network to recognize objects regardless of their position in the image. So let's understand what a typical CNN processing pipeline looks like. So you have your image that goes through a convolution layer. Post the convolution layer. So in the convolution layer, typically the input image or the feature map is convolved with learnable filters or kernels. That is what we learned during the training of a CNN. Then each of the filters slides over the image, computes the dot products, and it generates something what we call as feature maps. And then these filters that we use are used to detect edges, textures, and patterns at different levels. Once you are done with the convolution layer, we move on to the next layer, which is the activation function, or ReLU in this case. So after the convolution, a non-linearity is applied, and ReLU will simply replace your negative values with 0, and it will act as a linear function for wherever your values are positive. What this does is it helps introduce non-linearity and helps the network learn more complex patterns. And finally, when you are done with ReLU activation, you move on to the pooling layer. So pooling would typically reduce the spatial dimensions of your feature maps, and this will reduce the number of computations and helps retain dominant features while removing the noise which is there, right? And the most common pooling techniques that exist are, let's say, max pooling. That's the most frequently used one that you will see. There are others like mean pooling and min pooling, so we'll have a look at that. But let's first quickly recap how does pooling work. So let's say that this is the feature map that you end up with post applying your convolution and ReLU. And now what happens next is that whenever you do this, so this is the feature map, and now there are two things to keep in mind here. First one is the pool size and second one is the stride. So pool size is essentially what window you would consider to apply pooling, and stride is by how much you are moving forward, right? So if you have this input feature map and you want to apply max pooling on top of that, so this is the first matrix or the block of this particular matrix that you will consider, and you see that in the block that I've highlighted in red, the maximum number that you can see here is 3. Then if you have a stride of 2 and you move forward by two blocks, so you have this second block that is starting from this -2 and then ending at this one. So this 3 cross 3 block here, you see that the maximum value is 4, therefore we have 4 in this one. And again, you can see that similarly if you apply it to this one, the maximum value here is 6. That's what we have mentioned here, and similarly for this one it's 5. So this is how max pooling would work. Similarly, you can do min pooling where you would take the minimum of these numbers instead of the maximum, and there is mean pooling where you will sort of take the average of all these numbers that are there in this particular filter. So this is how the max pooling would work, and you see that you have reduced your input feature map from 5 cross 5 to essentially 2 cross 2. So that will reduce the number of computations, and max pooling would help retain the most important features, right? And that's why it's a popular choice in CNN architectures and designs, because it highlights the most significant features that you can have. So that's why you would go for something like a max pooling. So once again, let's quickly recap before closing the video. You have an input image, it goes through a convolution layer, you end up with a feature map which you pass through ReLU. Post ReLU, you end up with pooling. And once you are done with multiple blocks of convolutional ReLU and pooling for a deep CNN, at the last layer, you would typically flatten whatever output you get, and you will pass it to a fully connected layer for, let's say, a use case that you might be solving, like let's say a classification task. So that's how the entire thing would work. And we'll just quickly recap why use pooling. So the first point was to reduce the computational complexity. Without pooling, the feature maps would be large and therefore require more computations. Pooling will reduce the width and height of your feature maps, therefore reducing the number of parameters. The second one is it helps maintain translational invariance. So small translation of objects in an image should not affect the classification, and pooling ensures that slight shifts in the position do not drastically change your feature maps. The third one is it controls overfitting. So by reducing the number of parameters, pooling prevents overfitting in CNNs, and it retains only the most important features that helps generalize better. And the last one is the extraction of the dominant features. So like we saw in max pooling, only the strongest activation is kept, and this highlights the most significant features in a given region. And these are all the reasons why you would want to go for a pooling layer in your CNN architecture. So it was a short yet fundamental video, but then again, it helps revise and refresh some of the concepts that you would have learned long back. Or if something, or if this was something new that you have learned, then definitely do appreciate by pressing the like button and subscribe to this channel for more such content around Gen AI and basics of data science and machine learning, and more interview questions around these topics. Thank you so much for sticking till the end. See you in the next video. Until then, take care, keep learning. Bye bye.